Hello everyone. How are you all doing? Thank you all for joining for the second workshop of the Stellar Encode Educate series. It's lovely to have so many of you here again for for our next installment. I'm doing very well, Charlie. How are you doing? Last time we had everyone say where they were from, so feel free to introduce yourself again in the chat. I'd love to hear where you're from, how you're doing. Hopefully some of you are a little bit familiar with everyone and can recognize people from the chat that were here last time. I can see a couple of people are still joining, so I'll just give them a little bit more time before we get into things. But yeah, very excited to kind of see you all again and to get started with another very exciting workshop. I'll be kind of giving you a brief overview of kind of what we did last week for those of you that weren't able to attend, and then we'll be hearing shortly from Morgan from Okashi, who will be able to give us a very interesting talk that will hopefully build on the introduction to Stella and Soroban that we had last week. But yeah, lovely to see you all. You can see we've got people from Indonesia, Kenya, US, a Colombian lost in London. Unfortunately, you found yourself in a very rainy city, which potentially contrasts a lot with your hometown, wherever that may be in Colombia. But yeah, I think we'll be ready to get going in a moment. I can see the numbers seeming to stabilize a little bit, and then we are ready to go. So yeah, welcome everybody. Again, this is the second installment. If you haven't had the chance to watch our previous workshop, I would really recommend that you, after this event, that you get the chance to go back on it. I will add it to the chat now, just so that everyone has it. This is the YouTube recording for those that missed it, and I'll be able to plug that in again. And so, yeah, that was last Thursday. We heard from Omji Park, who is the head of research and operations at Encode Club. We covered Stella's general architecture and features. And we also started delving into a bit into Soroban, which is a Rust-based smart contracts platform, which integrates and works alongside the existing Stella blockchain. Today, we've got introduction to Rust and Soroban without leaving the browser. This should be a little bit more of a technical workshop, but you don't need to worry that you don't have like anything, nothing was needed to download in advance. Like Morgan will be able to run you through everything. And then next week, I was just waiting for the presentation to update. Then we have another workshop from Julian Martinez, who is a senior developer advocate for the Stellar Development Foundation. And you will be developing a first dApp on Stellar, which is very, very exciting. And hopefully you will build on from today's workshop. And then finally, we will have in the 22nd of February, a virtual workshop on data indexing. So looking at dApp efficiency. And in that sense, you'll kind of be really building on skills from previous workshops that then can be applied to these final ones. So yeah, as I said, after the introduction to Stella, we have this fun kind of building session with Okashi. This is a more technical workshop, so you'll be able to see how you can use Rust to write Soroban smart contracts and deploy them onto Stella. And specifically, this will be done through Okashi, which is a sort of smart contract playground. And yeah, if you have no experience with Rust or Soroban, please do not worry about that. We will be going from basics, and hopefully this is understandable for everyone. So I will now be inviting Morgan to take to the stage, who will be able to start his workshop and give an overview of his presentation and get all the more details.
Hi to everyone that's joining in. I don't see the entire list of people that's in the chat, but I assume from the messages coming through that there's quite a bunch of you. So hey, my name is Morgan. I'm the founder of Okashi. Like Michael said, Okashi is a playground experience for Soroban, and I believe today you'll get to see how nice and easy it is to get started on Soroban. It's going to be a little exploration, a little discovery session, and yeah, join me in the process. So what we have here is okashi.dev, which is a website anyone can go to, and you're greeted with this call to action where you can open up a playground. So let me go ahead and create a new project and introduce you to the canvas that we'll be using. And the word canvas I picked specifically because I look at developers as artists, as creative people, as people that take an empty canvas and create something from nothing. So think of Okashi as your first canvas for Soroban, and let's get going. So what we have here is like a bento box layout where to the left, you have a bar where you can control the user interface. This expands your project explorer if you have more than one project. And over here you have widgets. Now that's the word I'm going to be using throughout this workshop. So there's different widgets that enable different features in Okashi. So now my favorite thing, which is how long does it take for you to build a smart contract from zero and execute it in Okashi? Is it a replacement? So I'm going to be replying, I guess, to the chat as well. So United Coin is asking, is it a replacement for VS Code? It is not. This is a playground experience. So it's an integrated playground experience where you can test things out, you can explore, you can discover, you can find something you can build, and then transition once you're ready to a more professional setup like VS Code and shipping it. This is very much a learning experience. So now going back to the zero to contract. All right, so when we created the project, we have some boilerplate code. Click compile, which is going to compile that into an executable, which is then contained in this section here under contract. And the public functions of your contract become buttons. How do you interact with them? You click them, okay? So we're just going to say hi Encode, okay? And that's it. So we went from, we didn't have a contract to a contract in, I don't know, a few seconds. Now, as far as it looking like Remix, we can have a whole nother discussion about that. This is a different category of product. Like you were just able to see, we compile a contract with a button. We call the contract function with a button. Everything's human readable and instant feedback. Can we zoom in a little bit? We could, but that's gonna have some issues. But I guess for this part, we can zoom in a little bit. All right.
Is that better for everyone, just so we can see their opinion? I think you've gone one more zoom. Yeah, I think that seems to be good.
Yeah, I think we're like 150 or 175%. Yeah, we can go all the way, but there's a range that's viable here. All right, so here we go. We're calling a contract by clicking on this button. We have an input. By the way, if your inputs do not change between function calls, you can just hold down Shift and quickly call your contract. And this instant feedback is enabled by Okashi because it's running in your browser. All right. So now that we've gone through this whole concept, this whole flow of I create a new project in the playground and I compile it, I get a contract, I call it. Let's explore a little bit about what Soroban is. So and we'll start with Rust. Okay, so what we have here is a Rust program. Okay, now Rust is a programming language that is a little different if you're coming from the scripting languages world like JavaScript or Python. Okay, so let's go and get ourselves introduced and familiar with Rust. So what is Rust? Rust is a compiled language, which is a little different from JavaScript or Python, which are scripting languages, which you can execute directly in your environment. Rust needs to be compiled. There's a beautiful tool chain for compiling Rust called Cargo, but as a developer that's just getting started, you don't need to learn anything about that. Okashi does that for you. So all you need to do is write some Rust code. Now this boilerplate, I'm going to explain sort of all of it line by line. Line number one, we have this macro, which is meta programming. It's not the language itself, it's meta programming. So this is going to affect the program, but it's not like specifically a part of the language. And this indicates to the compiler that please do not include anything from the standard library. The standard library for Rust includes all kinds of types that require memory allocation. And Soroban is special in the sense that it does not yield itself. It does not yield itself to memory allocation. So you have to work with statically allocated memory, and for that reason, to save on the size of the binary that you'll be shipping, we include this directive here to not include the standard library. Standard libraries are pretty common practice in you'll see you see them in JavaScript, like math and number and so forth are part of the standard library. So Rust has a standard library, but there's also stuff that's called the prelude in Rust that contains the basic types that we'll have to use. Next, the second line, we're importing the Soroban SDK, which is really the only thing that we can use in Okashi as an external resource. And right, it's the only external resource, the only external crate that you'll be accessing. And crate is the Rust term for package, like in JavaScript you have npm packages. In Rust you have crates that are handled by Cargo. So Soroban SDK is the official Soroban package. It includes several types. Now over here there's two definitions. One is the definition of a struct called contract. Now the name can be anything. The important thing is the directive, the macro here that says contract above it, right? And that enables the compiler, along with the Soroban SDK, to create a specification for your contract that will be used by anyone that's trying to call your contract. And specification is just another way of saying like an API for your code, for your contract. Okay. All right. So that's going through a little bit of the boilerplate. Now this declares the struct, which is structs is a compound data type, and then this implements the struct. So it's like you can think of it in terms of JavaScript a little bit like you're declaring a class, and these are the class methods, something like that, where the functions that you declare over here will be accessible. Now, let's get started with a function. So we're going to declare a public function, or I guess we can declare a function that says hi. Okay, let's compile this. Now, we compiled and everything's fine, but Okashi says that there's no public functions, okay? And the word public here matters. So let's add the word pub, the keyword pub in front. And what this alludes to is Soroban exports or creates a specification for the public functions of your contract so that others can easily call those. If you don't declare the keyword pub in front of it, then your function can be used within your contract, but others won't be able to call it. All right, so now say hi. What does that do? Well, I think we can sort of replicate the initial setup. I'm going to add an argument here. So when you declare functions in Rust, the first declaration here with open parens, close parens did not have any parameters, but your functions can have parameters. So here's a parameter called env. Now, this is a sort of a special concept for Soroban, where every public function in your contract, if it takes arguments, it needs to have the first argument as the environment, or env. Env is the execution environment. This is where Soroban contracts get executed. Now, you're also going to have access to, you're going to need access to the environment if you're using things like log. Now, I'm a huge fan of console log in JavaScript, okay? So I'm just going to start using it right away. Now, log is a macro, and when we're calling a macro, we're going to use the bang or the exclamation mark. So yeah, and the first argument in that macro is the environment, or a reference to the environment. And we're just going to say, hello, everyone. Okay, let's compile this. And what do we have here? We have hello, everyone in the console. So isn't that beautiful? In this environment, you can log values while you're writing them out. Okay, so the console log in JavaScript in the web world is an eye-opener and an enabler for a lot of people to learn and understand how their code works in sequence. All right, so let's explore some Rust concepts that we have. The basics down. I'm just going to rename this first, and this is going to be like a container for us where we put our first strokes on our canvas in terms of the Rust code. Okay, so how do we declare a variable in Rust? Let's do that. So let number equals 10. Okay. Now I'm going to be using console log a lot, or log rather. And if you want to print a specific value in Okashi, you can put these curly brackets as placeholders, and then after the string literal, you can provide the value, and that will get printed in the console. All right, so first, number is 10. So we declare a variable using the let keyword, the name, and then we assign a value, a literal value. Types, so Rust is strictly typed. Now, types are inferred from the context, and you don't have to specify them in almost every case. They're inferred, but sometimes you need to specify them explicitly if you want a concrete value. So like this literal number is actually an assigned integer. I can make it an unsigned integer that's 32-bit wide. And, just as easy, it's still 10. Now, I will be able to have -10 as the value because this is an unsigned type. So this integer type does not have a sign, okay? And this introduces us to the compiler widget. which you can find over here, the hammer icon. Yeah, it'll be helpful along the way while you encounter bugs in Okashi to debug those problems. And the Rust compiler has probably the best compiler messages in the industry, explaining users their mistakes and providing suggestions. So you can hover over the issue and it'll highlight the line that has the issue, in this case line number 10, and we can go ahead and fix it and recompile it, and we're back. So number 10. Okay, so this is how you declare a variable. Now variables can vary, right? So let's set variable number to 11. Charlie's asking, are these messages, error messages, aligned with the standard ones in Rust? You are correct. These messages are piped directly from the Rust compiler, Rust C, and we're just sort of decorating them in Okashi so that you can reference them more easily. So you have warning messages and error messages. Warnings are orange and errors are red. Okay, so we tried assigning another value to a variable, and that didn't work. Cannot assign twice to a mutable variable. Okay, so this brings us to the second concept of Rust, and I would like to call this a happy accident. And I guess a lot of this workshop will be us discovering things by making happy accidents along the way. So it says cannot assign twice. By default, Rust variables are immutable. Okay, immutable just means they cannot change. If you set the value, that's the value it's going to be. We can change that by using the mute keyword. Let's go ahead and recompile this and call it again. So this variable is now mutable, and we can change that value as much as we want. A concept that's pretty unique to Rust, and I wish JavaScript would have that, is variable shadowing. Oftentimes, your variable can change the value and how it's declared. Sometimes you import a string of a number, and then you convert that number string to an actual integer value. And something like JavaScript, you would need to create a new variable name because you can't reassign. But in Rust, there's a concept called shadowing. So I can technically do this. So line 10, 11 do not conflict. And what happens here is I'm taking this identifier and I'm reusing it. I'm shadowing that value. And technically, this is like me declaring a brand new variable, and it can have a different type. It can be, a boolean, and that's okay because we're recreating this as something else, and the compiler will deal with everything. All right, so those are variables and mutable variables, and let's just have an instance of a mutable variable present on screen so you can have that number. Let's recompile this. Rudolph is asking, interesting, would making it mutable use less memory than the shadowing, since I assume it needs 2 storage locations? Yes, so Matthias has an answer for that. What happens is after line number 10, if you're shadowing that variable number, your previous value goes out of scope. So that is released from the memory. So you don't have an old number holding some value and a new number holding another value and using twice as much memory. You only have the memory that's allocated for the type, the most recent type. Okay, so then we have constants. Now, these are variables. Some are mutable, some are not. But there's also a thing called a constant. So constants are specific values like number 1, and they have a couple of requirements. Let's learn about one. So here's the compiler helping us again. It says missing type for const item. When we're declaring a constant, so a thing that never is going to change, we need to explicitly tell. So Rust is not going to go ahead and implicitly decide what the type is of this variable. You have to explicitly tell it what the type is. Okay. So that's one of the quirks here, and we can go ahead and log this as well for our convenience. Number 1 is 1. Okay. Now, there's, I guess, a good point to mention about the naming schemes. So far, everything sort of looked normal. I guess in every other context, you would get a similar thing. But Rust uses a couple of naming or formatting schemes specifically. So let me talk about those. So first up is that constants are all uppercase, capitalized uppercase characters using this underscore to separate words. Regular variables and function names and everything else is using the snake case. So snake case equals true, which means that the compiler is going to be highly suggestive if you use something like snake case. Okay. There you go. So over here, it's telling us that variable snake case should have a snake case name. I find it a little bit funny that the language in the compiler itself dictates this to such a level, but that's the case in this instance. So when you're naming things, always make sure to name things using the snake case. When you're naming your constants, make them uppercase. When you're naming your types, like structs and enums, we'll talk about those a little bit later, always start with a capitalized first letter. Okay. We see some questions in the chat. Charles is asking, is Soroban SDK the only library that can be imported, or is it more generic? So Soroban SDK is the only library that's supported on Okashi at the moment because it's a player-run experience, but you can import other libraries that work with the standard no stud flag. And it feels to me like it's being okay. So hopefully that answers it. All right. So now we have constants, variables, mutable variables, and variable naming schemes. We're going to talk about data types now. So let's create a second function here, which is going to be like our chapter markers almost. Okay. We can minimize first. We'll be able to get back to it if we need to. Okay. So let's log second. Always a good sanity check. Now you'll see a second button pop up in the contract widget, which allows us to call the second function. Pretty neat. Okay. So what are the data types? And data types in any programming language is, what values can we work with? Links to learning these resources. Of course, I'll be able to share those links afterwards. All right, so what are the data types? Well, there's I guess, two types of data types. Let's start with scalars. So scalar types are basic types that have a fixed size in memory and contain only one type of value. So let's go through some of them. Let's go, I guess, A is going to be assigned 8-bit value. So it can go from, minus 128 to positive 127. And let's go ahead and log that value, or log a bunch of values, I guess. Now, here's a quirk that I'm trying to rectify. Oops. When you're using log and you have values that you're sending to log to print, this works in a world of Soroban, and for that to work, that specific type has to be able to be transformed into this thing called val, which is an internal umbrella type for Soroban values. And unfortunately, small integer types are not supported. We can experience that over here. So when you see something like this, trait bound Soroban SDK val is not satisfied, that's because Soroban does not encode integer, small integer types, byte-sized integer types. So we have to convert them to something that gets that's supported by val types. All right, so we have, and we're going through the Rust types. So we have signed 8-bit long integers. We have unsigned, and fun fact: if we want to take the max value for a specific type, we can just do : and we'll be able to get the maximum value. What's the characters before I32? Are you talking about this section, the as? This is a typecast where we're casting this specific variable to a different kind of type, so that Soroban can print that value because it doesn't understand these smaller values. All right, so we have these smaller types, which are pretty useful, especially when you're dealing with ASCII characters. So like a byte long, or I guess 7 characters encoded into 7 bits. You'll get to experience some of these values that become useful. But you'll see more often things like signed 32-bit values, like let's see what the minimum value of that is real quick. And by the way, I'm recompiling this often and seeing these outputs because it's a nice way to learn. It's a nice way to learn and understand. So we can see the minimum value for I32 is -2 billion. So then, you have a U32, something, and then we go a step higher. Let's do these min values again. I like those. F would be the unsigned version of 64. Then we have actually the top of the range for Rust values, but he tied Umax where he gets the value of U8. All right, so I think we have some confusion in chat, and let me address that. So is U8 an object from the Soroban standard library? No. Right now, all these lines over here, we're declaring native Rust number types, specifically native Rust integer types. The first character here, I and U, they stand for signed and unsigned. Okay, so what this basically means is a signed integer, like this signed 8-bit integer, can have values that go from negative to positive in a specific range. And unsigned, meaning you cannot have a number with the minus sign up at the front. You can only go from 0 to some maximum value. Okay. All right. So I think Charlie's coming along. And yeah, so Rust contains various integer types, and I guess scalars with native Soroban support. This is probably a good way of phrasing this. So these get encoded, and so we're getting bigger numbers. I-128. Let's see what's the minimum value of an I-128. That's G, right? And we don't need to cast this anymore because these types are natively supported by Soroban. So let's see what the value. Ooh, that's a pretty big value, or I guess small value if you look at the number type. Charlie's asking, so calling U32 max would print a larger one. In fact, let's go ahead and do that. U32 max. Special request by Charlie. Okay. So here you go. This is the U32 max value. All right. So yeah, we're going bigger. We're getting bigger numbers here, and these are still native Rust types. Let's do U128 max. Print that. By the way, there's a nice keyboard shortcut, Command K, which I like to press, and that's a pretty big number. Pretty big number. Now, Soroban does support bigger numbers, even bigger numbers, and we'll be able to talk about those when we get into Soroban types. Right now, we're going through native Rust types. So these are integer types: scalar, integer, or yes, Rust scalar integer types. Okay, that's one section, and perhaps we can open up a block and close it. I'm just organizing this beautiful document here so that we can have a nice organized space. Is there any performance or security benefits or otherwise of using IUI8 instead of native Soroban types? The 1 byte long integer types are specifically useful when you're dealing with things like ASCII characters, string literals, and you want to initialize those using sort of hard-coded values. And I guess I can talk about a little bit about sort of initializing or literal Rust integer literals. Okay, so I'm going to be shadowing something, a number, let's call this, all right? So you can declare a million like this. Go ahead and log the value. So I believe that's a million, right? But it's a little inconvenient to read, and you can use this literal format using the underscore to separate the digits, and you still get the same value, which is very nice. Now, another way of declaring a number is using the hexadecimal format. So this is, for example, all right, let me test this out. Who knows what kind of number this is in terms of a decimal integer? FF. Come on, we gotta have -1. Okay, we got one guess. 256. 255. We have a variety of answers. That's lovely. 32. Paul says 32. All right, let's test it out. The best answer is us compiling the program. Is 255. So whoever got it, 255 to Charlie, Aryan, congratulations, you got it right. It's 255. So this is useful when you're working with bytes and you want to declare byte long numbers. So 2 hexadecimal numbers always equal 1 byte. And if you have 4, that's 2 bytes, that's 3 bytes, that's 4 bytes, and so forth. And you can also use the separator here as well, same as before. All right, so now let's declare another number literal, which is binary. So this is going to be another interesting question. All right, so what does this print? What's this in binary? Oh, sorry, I made a typo. We got 4 ones and then 4 zeros. Is this too hard? Should I make it easier? Let's do 4 ones. Okay, let's make it easier. What's this number? Anyone engaged is gonna 15, Rudolph says. Okay, we got one guess. 16, Dinesh. All right, 2 guesses. I guess we can 3, 4. Okay, interesting. So we're hovering between 15 and 16. Well, let's see what the compiler says. It's 15. It is 15. And sorry for my sort of geekiness around this, but I want to go through this. So the way you encode numbers in binary, you just sort of each one indicates the power of 2 that you need to add to get the total. So the first position is the 0th power of 2, which is 1. So we got 1 plus the first power of 2, which is 2. So 1 plus 2, we got 3. Then the third position is 2 to the power of 2, which is 4. So 4 plus 3, we got 7. And then the last one is 2 cubed, which is 8. Okay, so 8 plus 7, we got 15. And that's how we get the number, the correct answer. Are we tracking time? I don't think, I personally don't have an allocated time. So if you guys want to, continue with me, we can continue. But yeah, all right. So these are the literal values for numbers and integer types. Let's go ahead and hide this away. Crank it up. All right. So let's hide this and Rust Boolean. So this is a fun type. Okay, so let truth be equal to true. And let's go ahead and log this value. Truth equals truth. Okay. Wonderful. Truth is true. So a Boolean type can have one of 2 values, true and false. And it's natively encoded in Soroban. You can print that. So that's very lovely. That's the second sort of scalar type, or a category of scalar types, I guess. All right, now let's explore tuple types. Rust tuples. Now, what's a tuple? If you're familiar with Python at all, then tuple should be very familiar. I guess if you're coming from JavaScript or the web, then tuple will sound a little weird. So let's go ahead and declare one tuple. Tuple equals this thing, and let's try and log it. All right, so what is this? What is this? A tuple is a collection, a fixed-sized collection of values. Now, those values can be anything. It's not specifically required that they be of the same type. In fact, we can declare them to be different types. So U32, I32, and it'll still work. By the way, this is how you declare a tuple type, which is very fun. And you can even have a boolean in there. Why not? Let's print this out. And yeah, I guess these are the types that we're familiar with. So let's stick to that. Right. Now, finally, so these are the sort of the compound types, I guess. The Rust compound types. And I guess the last one would be an array. I'm seeing some questions over there. You have to, all right, so United Coin is telling us that for Windows, we have to click Control-Shift-K to compile. And I do apologize, all you Windows users out there. I'll take a note of this and enable Control-K compiling. This is optimized for a Mac at the moment because that's the machine I'm using. But yeah, thank you for the suggestion there. All right, so what's a Rust array? A Rust array is a fixed size array. So we used sort of the regular parentheses. Now we're using square brackets here. So let's declare this type and log it. All right. Oh yeah, regular arrays are also not natively supported, but we'll be able to print those values in a different format later on. Okay, so we've gone through compound types and scalar types. Let's go ahead and, so we've been declaring functions previously, right? We have the function first, function second. Let's declare pub fn third, okay? Now, let's see here. So, let's see. So let's say we have a function that's going to increment a value, right? So it takes in an argument, a number. That number is going to be type 32. And if we want to increment that number, well, I guess we need to add 1 to that number. Now, since we're, we want to use this somehow, we need to tell the compiler that it actually returns a specific value. If you're coming from Python or JavaScript or any of the other scripting languages, you're used to doing this: return number plus 1. So let's go ahead and with this syntax, and I'll explain a little bit later something else. So let's say number equals 11. Then we're going to do a log of what the number equals initially. So we're just going to pass number. And then we're going to log number after we increment it. So increment number. So we have our third function here. Let's go ahead and call it. Okay, so we have 11 and then we have 12. Okay. Okay, so we have 11 and 12. Now, if you're used to JavaScript, you're used to Python, return this, makes a lot of sense. And you can still use that. However, in Rust, there's a concept, I guess, that's very useful to learn, because you'll see this being repeated in many instances throughout different code bases. And the concept is the difference between statements and expressions. So line number 8 over here is a statement, okay? And a statement does not return, a statement doesn't leave anything for the left-hand side, so to speak. I guess we can try and illustrate this by doing a comparison. So let's say that A is equal to 10. So this is not a statement, this is an expression, and we can assign expressions to variables, and we can also return expressions. And by default, in Rust, the very last expression in a function body gets returned. Let's see how that works. So we still get the same output, 11 and 12, but we no longer have a return number plus 1 and semicolon at the end. Now, the difference here is, instead of using a statement, a return blah, 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 we're doing an expression as the very last thing. And the critical thing here is the lack of a semicolon. Okay, there's no semicolon at the end, which otherwise would create an error. And we can discover that nicely over here. So mismatched types. This is expecting a U32. If we don't have a return statement and we don't have an expression at the end of the function body, then Rust implicitly assumes that the return type is an empty tuple. An empty tuple. Okay. Now I made this work, but you know, we got an empty tuple. That's not what our increment function should be returning. So let's go ahead and fix that. Let's remove the semicolon, and hopefully everyone's here with me as to expressions and statements. We'll be able to explore that further as we go along. It can become very useful in instances like, for example, number is 11, right? What if we want to, you know, have an intermittent value of 10 and then do x plus 1? Oh, sorry. We can do that because, thank you, Matthias, an empty tuple is called a unit in Rust, which is sort of like the void type, I guess, or the null type. You can find similarities in other languages. All right, so we have this very nice way of evaluating expressions and assigning them in line, which is very powerful, a very powerful concept, and you know, lovely thing to have in the language. And this works for every block context, so, or every scope rather. So a function has a scope. These curly brackets create a new scope that evaluate to the very last expression, same as this. And you can sort of nest these things and create different logic through that. Okay, so we have statements and expressions. Now, when we declare a return value, we gotta make sure that there's a return value present, which you either do with the return keyword or by just having the expression last. Now, another useful thing is comments. Okay, so in Rust, you can do comments on a new line. You can end the line with a comment, and it's very useful and very nice. There's also, and you'll be able to sort of see this when we create the fourth function. There's also an extra thing that Soroban provides. But for that, we need to take an argument from our contract function. And what we're going to do here is going to be a little bit different. We're going to take a number and return that number, doing nothing with it. Oh yeah, missing a return type. All right, so we have our fourth function here. Now, you can see another interface feature of Okashi, which is if our function takes in arguments, and you can see those three little dots, not ellipses, in between the parentheses for fourth, that indicates that that function takes arguments. You'll need to provide inputs. Okay, when we click that, it asks for those values to be filled out. And we have the name of the function up at the top, the name of the label for the argument, which here in this case is number, and the type of that argument. So we can do, I don't know, 42 and call. Okay, so let's, like I was talking about comments, we can actually do documentation type comments. And this function takes a number and returns it unchanged. Let's compile this again, and you'll be able to see the nice abstraction that Soroban provides, which is we're able to see the description in the input modal, the arguments modal here. And we can also see that Okashi maintains the previous value that we had held there before. Okay, call 42. Now, I want to take the time here to explore a little bit the values, the Soroban value types, which are plentiful and interesting. And I guess starting with U32, which is a very common number type. So first, this input is going to help you out a little bit in that it's going to tell you when you've exceeded the boundaries for that number. So if you go too high, it's going to tell you that you've gone too high. And if you want to go, under the value that's the minimum value, you'll also be told that. And numbers cannot be empty, right? So we're going to call that, and we get that value. And this works for different types, right? So we can have, let's say, first is an I32, second is a U32, and third is a boolean. Okay, so we're going to return second here. Let's recompile this. So now fourth is going to take 3 arguments. Okay, now the modal is populated with those arguments. And the types are denoted on the right. Okay, and fun fact for Boolean, you just switch between true or false. So just do 33, 33, true. And if we don't want to return a value, I guess we can remove this and just log everything that's there. So we're going to log the first, we're going to log the second and the third values that come through function call. So let's do first, second, third. Recompile. Now it's going to remember all these values, so we can just quickly call. Isn't that nice? Okay. So we have logging of the values that we input. Okay. Now, these are the values that are natively supported by Soroban that are actual Rust values, but we can explore what types of Soroban values there are, or types rather, value types. Okay. So here's a fun one, vector. Okay. Now, a vector you should think of as like an array. In JavaScript, you would probably think of it as an array. In Python, you would think about it as a list. So it's a dynamically sized collection of typed values. So you have a specific type. Now, how can you start using that? Oh, I see a question. Rudolph, in the real world, is it assumed that the input to the contract function number will be automatically cast to the type of the argument? So I see what you're asking. So is there a backstop that sanitizes values? Well, the system will reject when you're sending values to the network. And the network's evaluating, or Okashi's evaluating, that value gets encoded as a specific binary data format called XDR that's used for scalar encoding, and that's pretty explicit, and it doesn't accept values that go outside of the value ranges there. So that could be a backstop. And at the end of the day, the environment, the execution environment, will not allow those numbers, if those values, if there's a mismatch to go through, you'll just get a host invocation error. And yeah, but sanitizing, I guess, user inputs, if you're thinking about a dApp context, which is like a web app, you got to do that. Because otherwise users will just sort of wait for the transaction to get refused. All right, so let's explore the vector type. Okay, so to use the vector type, we have to import vec. Okay, and we're going to take an input. So let's say vector is a vector of. Now, in Rust, you have these types that can have sort of variable associated types. So vector itself is a container type.
Amazing.
So vector type. So a vector type is a composite type, and we have to use these angle brackets to declare exactly what that type should be for that container. All right, and we can just print that value in the console. So this is going to be fun. Let's recompile it. And now, if I click this, I get an error. Oh my Lord. What did I do wrong? A vector of U32. Let's, I'm going to go back a little bit to my reference. One moment. Okay. I guess that was a temporary issue. Okashi is a product that's in development, and yeah, if you run into issues, please let me know, but let's move on. So fourth is going to accept a vector argument. I guess we can change the documentation comment here. This function takes a vector of numbers. Okay, let's recompile it. Boom. All right, so how do we populate a vector? Well, this plus button over here is a suggestion. So go ahead and click that, and we have an input for a number. So let's go 11. Let's add another number. Let's go 22, 105, and I think that's going to be enough. If we add one more value and that's a little too much, we want to change this list, we can delete the values from the list. And let's go ahead and call. So in the console, we can see that our vector here contains three values. And it's 11, 105, and 111. Now, it's very useful to go into the documentation and explore all the things that you can do with a vector. And under the implementations section, there's all these functions that you can call on a vector. So for example, we have this get function here. So it takes, it returns the item at position or none if out of bounds. Okay, let's go ahead and try that. So beyond just printing the entire vector, we're going to call one of the functions here. So let's do vector get and 0. Okay, let's call forth. So now I had the shift down, and it called with the same arguments that I had before, which is very useful when you're dealing with complex input types like a vector value. You don't want to recreate this every single time you want to call, so you can just sort of use the persistent value there. All right. Now, we were able to get value 11, which is the value that's at the very first index, or the Soroban vectors are 0 indexed. So the first member of a vector is at index 0. The second one is at index 1, and so forth. We can see 105 over there. Next, we can see removal. So it removes an item at a position. So this is going to be very handy that we can log our vector. So let's call it remove F1. Vector as mutable, as it is not declared as mutable. Okay. Let's right. It's a immutable type. I want to get to the literal. Here we go. So if we're here's the method that I really wanted, len. Okay, so we can get the length of a vector. Length is 3. If we add another value like 105, call it, we get length 4. Now, I want to explore other types, and there's another pretty big type called map. Here we go. So a map is a collection of key value pairs. Okay. So we can go ahead and create a fifth function, pub fn fifth, and declare a map. Now we can import map from the Soroban SDK, just like we did with vector. But the difference here is that, let's return that map too, or let's not return that map. The difference here is that this contains 2 types, not just one. So we got to declare the type of the key and let's say the type of the value. So it's going to be a map that maps numbers to Boolean values. And let's use our handy log to print out the map. Okay. Nice. Let's call it fifth. So we got a similar interface to our vector input interface. If we click plus, then we have at the top the key input. So let's say 42 and true. And then we can add multiple values. 11 is going to be false. And let's call this. So this should be pretty reminiscent of your object types in JavaScript or your dictionary types in Python, where you're mapping from a key to a value in here. Okay, so we have map types. Then we have strings. Strings are very interesting. Symbols and strings, I guess. So we can explore. Symbols first. Symbols is a. Well, I guess let's look at it first and let's explore it afterwards. So, what's a symbol? What is a symbol? Now, instead of printing or logging, I'm going to return that value, and it's going to achieve the same results. Charles says it's a nice interface to define maps. Thank you. All right, so what's a symbol? This is a reduced character set string type for Soroban. These symbol values can get encoded in a single 64-bit integer value, which in some instances is very useful when working within the Soroban environment. So let's say I'm going to write hello and call this, and I get to print out hello. Okay, now it's going to complain if I try to do something outside of the character set. So an exclamation mark is, an invalid character. So we can use alphanumerics, uppercase, lowercase, 0 through 9, and underscore. All right, so those are symbols. Next is a string. So string is super useful, super familiar, I guess, to everyone, and it's lovely that Soroban supports that. String, and I'm going to return a string. Okay. So now string is your familiar type of string. You can do any kind of UTF-8 compatible thing. The difference is going to be highlighted in the Okashi interface in the console with the usage of single quotation marks and double quotation marks. So when you see single quotes, you can know that, hey, this is a symbol. If you see double quotes, that's a string. Okay, and you can see more about symbol and string in the documentation. And yeah, learn about those. They're very useful and handy. Okay, so we've gone through symbols, strings. Let's see what else is in there in the supported types. So we have time point and duration. In the meantime, Paul is asking, is Okashi dynamically bound to the Soroban SDK? Meaning if the SDK suddenly allows more strings in the spec. So Okashi is using a client-side implementation of the Soroban SDK. So meaning if anything changes in the underlying Rust SDK, there's work involved for us to make it compatible with Okashi. It's not automatic, unfortunately. All right, let's explore duration and time point, which are interesting values. So pub fn time. Okay, so this is going to take a time point value and going to return the time point value. Time. Okay, we got to import it from the SDK. So anything that we use in these types that's not a native Rust type, we need to import from the crate. Okay. So this looks like a regular integer input, and in fact, it is a regular unsigned integer type, 64-bit long. In fact, what does it do? Well, let's see. So if we put 100 in here and call, we can see in the console here 1,971. What does it look like to you guys? Let's do a chat chat poll. Epoch time. Paul got it. Second since epoch. Rudolph. Yes, very true, very correct. Time point is the number of seconds from the Unix epoch time, which is 1970 January 1st, midnight. Okay, and if we put 100 seconds, so that's going to turn into 1 minute and 40 seconds after the Unix epoch. Okay, this is useful for doing things in your contract that are time related, like if there's a specific unlock time for your assets or whatever it may be, you might want to use time point for that purpose, which is going to be either an input or available through the environment. All right, so that's time point. You can read about it again in the documentation. There's from Unix to Unix function calls. Yeah, that's correct, epoch time. All right, so then let's do, what was the other one? Duration. Okay, let's do duration. So v duration, and duration. All right, we need to import this as usual. Okay, now this again is taking duration, but looks like an integer type. Let's do 100 and see what happens. Oh, let's not do 100. Let's do 10. Okay, so similar to Unix epoch time point, this is a duration in the number of seconds, and Okashi sort of converts that into a human readable format. So if we have 100 here, it'll be turned into 1 minute and 40 seconds. Or if we do a pretty big number, it'll go one day, 3 hours, 46 minutes, 40 seconds. So that's something that you can play around with in conjunction with time point to have that extra semantic value when you're dealing with time related types. So instead of using just pure integers, which you can also do, but this is recommended. All right, then there's bytes. Okay, so bytes is an interesting type. It's just a sequence of bytes that are natively supported on Soroban. Again, is going to have a custom input type, and let's see how it looks. So your input can be one of two different variants, either a base 64 value, which looks something like this, or a list of integers, something like this. So let's go ahead and do 1, 2, 3, 4 in terms of bytes. And the console prints angle brackets and hexadecimal encoded integers for each byte. Sometimes you're going to be passing along bytes for things like addresses, or you might be passing along bytes for your NFT metadata or whatever custom stuff that you're encoding that you want to store that doesn't have a specific type allocated in the SDK. You can use bytes for that, just to store generic binary information. Just for giggles, I'm going to provide a base 64 value. And let's see what that prints out. Oh, it actually prints out the same thing. Just so that, you know, and it's printing the right thing. Okay, so we got bytes. What else we got? We got vectors, which we tried out, symbols, maps, strings. We tried them all. But it's not the end, because you can declare your own types. And to do that, there's this handy little macro called contract type. Okay, so let's go ahead and declare a contract type. Pub enum, and what should we call this? Let's call this skill. Okay, so what kind of skills can we do? Chat, I need help. What kind of skills can you have as a person? We're going to populate this enum with specific types of skills. Matthias is typing, Dinesh is typing. Engineer skill. We need more. Tech skills, mad skills. Mad is a skill. Cooking, all right. Tech and soft, okay. No other suggestions coming in, so let's do mad, soft, and cooking. Coder. I guess engineer fits into that. Nunchucks, that's one I like. All right, nunchucks. All right, so we declared a contract type. Let's compile this and see if you know, this works nicely. Okay, so now we can take this and have our function take an argument that's of type skill, and it's going to return that same skill. Okay. All right, let's compile this. Teaching. All right, so here's the Okashi interface for selecting your skill. It's a drop-down. It's all the variants that are available in your enum. You just select, let's say, engineer, and you get a printout skill to denote that this is of the enum skill, and it's type engineer. We can go ahead and pick cooking as a skill. And yes, Matthias, good point. So you need to use capitalized words for types. Okay, so we have skill, engineer, mad, cooking, soft, nunchucks. Lovely. Let's say that nunchucks takes a specific level beyond just that you're good at nunchucks, okay? You can have associated data with your enums in Rust. So this is Rust, still sort of native Rust, but it works with Soroban. So cooking, soft, those are skills without associated data. Nunchucks has a level, a skill level, right? So let's say I'm level 99 with nunchucks. And, you know, that might become relevant in a context where you're building out a game and, you know, you have skill sets, elite level. And you might want to have, you know, a specific variant, but also that variant carries some extra information. And you can encode that as a tuple. So this can have, you know, let's say nunchucks will take a boolean and a value. Oh, we got a crash. All right, so let's select nunchucks. Let's say we're true for, it's a true statement that our nunchuck level is 99. And we can, go ahead and use those values. Let's collapse some of this stuff. All right, so those are enums. There's different types of enums, by the way. So this is I guess you can call this a union type. This is a union, but there's also contract type. They're both declared as enums, but Soroban considers them, treats them a little differently. So let's, I don't know, do color. And a strict enum in Soroban would have an associated number value. So let's say, color red is 1, green is 2, and blue is 3. Okay. So that's, color. I'm going to just replace these and recompile it. I guess we've got to change the name too. All right, so this is color now. It takes a variant. Now, the interface is going to look the same, but underneath it, I guess we also have to declare that this is represented using a U32. So in Soroban, these two are treated a little differently, but in your code, you can sort of use them depending on what you need. These are encoded differently in the XDR. Pink, we got a pink fan. This would probably work nicely with associated data too. Anyhow, so yeah, these are enums, and these are enum unions as far as different types go. You can also declare your own struct type. Okay, so let's do pub struct and I don't know, person. How about person? And we're going to do name. It's going to be a string. And we're going to do a set of skills. All right, which is going to be a vector of skill. And yeah, let's do that. So this is a custom contract type called person with 2 fields, publicly accessible, name and skills of different types. Let's go ahead and create a test function for that. Person is going to take the person type and I'm going to return person. Okay. So I'm just going to do myself. So name is Morgan. And I'm going to add my skills. So let me think. I got engineering as a skill. What else? Not too good at cooking. I'm a little bit mad. As in, little loco. Have some soft skills. Anything else? Do I have nunchuck skills? Probably not. So I'm just going to remove that. And let's call this function. So you can see in the console, this is formatted as person, which is the type, the associated type name, and then the fields within that type. So name is Morgan, skills is a vector of the enum type skill. Okay. So this is sort of your playground, right? Your types, your functions, your inputs, your outputs, the different kind of colors on a canvas that you can put on. And believe me, with these types and these compound types, you can build anything you can imagine within the boundaries of the space that's allocated for a smart contract. And you can go, pretty wild. You can, if you can think it, you can build it. Now, I do realize that we've gone over time a little bit. So there's things that I didn't get it to touch on, but I would suggest picking up an amazing resource called the Rust book. So I'm going to share it in the chat. So if you're thinking about picking up Rust, this is a great resource to get started. I would explore that. Also, in terms of the reference for Soroban, this is the Soroban SDK Rust crate reference. If you want to read about, Soroban in terms of structure docs, go ahead to this link. It contains tutorials and guides and references as well. And lastly, if you want to experience and try things out in a zero setup instant feedback environment, try Okashi, okashi.dev. Play around with the widgets, compile stuff. And lastly, if you're able to do this, if you want to ship something to FutureNet or testnet, you can go ahead and go into the project settings, switch over to FutureNet, and deploy your contract to FutureNet. Your account is not funded on FutureNet. Let me go ahead and fund my account. So this is the account page. Click fund. All right, so now that we have a funded account, let's go into, I guess our first contract would be nice that's how we got started. Let's switch over to FutureNet and click deploy. Still waiting on that network, huh? We got some bugs. This should have deployed to FutureNet. There's been some issues with FutureNet lately. I'm going to have to circle back, but I promise you that eventually this will be ironed out. You'll be able to deploy it to FutureNet and to testnet. But yeah, thank you for tuning in. I hope you've learned a little bit about Rust. If you haven't experienced Rust before, I hope you learn about Soroban and the types that it has. And I hope you learn about Okashi as well as an environment. Thank you for the people that stayed here longer. Thank you for Michael for doing his job and staying much longer than expected. Thank you so much for moderating. And you can catch me on Twitter at SorobanDev. Yeah, thanks everyone.
Thank you so much, Morgan. Everyone's had a treat. They've managed to get double the amount of time today. So that was a really, really informative talk on Okashi, and I think that it's really useful, for people from different levels, especially people in the chat saying they're beginners and that they feel like they've really developed, and for people when they're already familiar with it, I think that they've definitely managed to learn something, and you can see people very grateful in the chat. So yeah, thanks once again, and happy to stay over time a little bit to facilitate this. But yeah, I think before we end it, I just have like a few important announcements before the end of next week. So I'll quickly share my screen. So yeah, obviously, like today, a massive thanks goes out to Morgan for his like introduction to Rust and Soroban. And next week we'll be developing on that even further, and we have another technical session lined up. So please do join again, same time next week. And you'll be hearing from Julian Martinez from the Stellar Development Foundation. And yeah, if you've ever wanted to build a dApp on Stellar, this is really the workshop to go to. So before you do that, however, I think there are just a couple of things you need to do. You have to have Rust installed and Soroban. I do have documentation on this for people that are unfamiliar, so I'll add that to the chat now. I'll also be following up on Discord for anyone that kind of misses this workshop or is kind of unfamiliar with it. I think I'd also like to clarify that in this document, the version of Soroban is different to the one that Julian was requesting. So please do look out for my announcements, because I'll specify exactly what you need to do. But yeah, I added it into the chat. In the doc, it says version 20.11, but you want to do the same, but just change the version to 20.2.0. But yeah, if that is confusing right now, I will be following up. So please make sure that you are joined as part of Encode's Discord so you don't miss any important announcements and any other requirements. But yeah, apart from that, please do look out for the recording. And thank you very much to Morgan once again. And I will see you all next week at the same time. So take care, everyone, and have a lovely rest of your evening.